Number 51. This kind of looks like a sine curve, S-I-N-E, which we'll be covering when we do some trigonometry. Let's see if I can... And yeah, that's a function. Everywhere you draw a vertical line, it touches only once. So this is a function. Number 53. These require some precision, which I can't really reproduce on this board here. It's a little bit clumsy using these things. The tip is so wide, you know, the width of the tip it exceeds the precision I need. So I'm going to refer you to your manual, your book, and the picture in the book. Let me see if I can get a close-up on screen with this. We have this graph. Part A says evaluate f of 0. Alright, so if we can zoom or get close up here. F of 0. There's when x equals 0, what's y, in other words? Or what's f of 0? Looks like y equals 1. Alright, so that would be f of 0 equals 1. X equals 0. What is y, or what is y equals f of x, you can say. And so what is y? It's 1. Solve for f of x equals negative 3. That's part B. Okay, f of x equals negative 3. In other words, y equals negative 3. You can always go y equals f of x, all right? So what's y, or what's x, when y equals negative 3? Well, it looks like there's two places that work here. Zoom in here. There's y equals negative 3 there, and there. What are the x values for those? Looks like negative 2 here, and positive 2 there. Alright? So x equals negative 2, y equals negative 3 over there. X equals 2, y equals negative 3 there. So you have two solutions. So there's part A and B. Number 55. We want to determine if this graph is a one-to-one function. And again, I'll refer you to your book for the picture. I can draw a rough picture up here. It's not going to be accurate. But I really don't need accuracy on this one, like I did on 53. It's kind of a oval shape here, ellipse. Well, is it a one-to-one function? Well, is it a function? Well, I do the vertical line test, and no, it's not a function. It will hit in two spots. What if it's, well, it's not one-to-one either, is it? It fails the horizontal line test. The horizontal line test will tell you if it's one-to-one, but these two spots there show you it's not. Alright, anywhere you draw a horizontal line, except at the very tips, will show you that it's not one-to-one. Okay, so it's neither one-to-one, nor is it a function. Number 57, see if it's a one-to-one function. Let me draw a rough sketch. Again, I don't need precision here. It's not going to be accurate with your picture, but it's not necessary. Something like that. Is it a function? Yeah. It doesn't fail the vertical line test. If you draw vertical lines, it only hits once. So let's see the horizontal line test. Is it one-to-one? Well, sure. Yeah, it'll pass the horizontal line test. Alright, so It's a one-to-one function. Number 59, is this one-to-one? Again, another rough sketch. I'm not going to bother with the labeling of the axes, but I just want the general shape. It kind of does this and then comes down. Alright. Well, it's a function. It passes the vertical line test, but the horizontal line test is where it fails. So draw a horizontal line in this area here above the x-axis, or even on the x-axis it appears. It will fail the horizontal line test. So it is a function, but it's not one-to-one. All right. Number 61, determine whether the relation represents a function. So we have a set of ordered pairs. You can consider any relation as a set of ordered pairs. Sometimes that helps when you're dealing with problems involving relations or functions. You can consider it as a set of ordered pairs instead of as a graph. All right, we so often use graphs because it's a powerful way of representing functions. But once in a while, it helps to remember that it's actually just a set of ordered pairs that you're dealing with. Here's a set of ordered pairs that we know is a relation, at least. Now, is it a function, which is a special kind of a relation? Well, a function, if it's not a function, an x-coordinate will be paired with more than one different y-coordinates. So, for example, if you had 3, 4, and 3, 5 instead of 4, 5, that would not be a function because the x-coordinate 3 would be paired with two different y-coordinates. Okay? But can you find that in this relation where one x-coordinate is paired with two or more different y-coordinates? Well, no. All of these x-coordinates are paired with just one y-coordinate. Now you could have 3, 4, 4, 4, 5, 4. It would still be a function, all right? Because the x-coordinate 3, 4, and 4, 4, and 5, 4, the x-coordinate is paired with just one y-coordinate. 3 is not paired with something else besides 4. 4 is not paired with something else besides 4. 5 is not paired with something else besides 4. So that would still be a function, okay? So there's your answer. This is a function. Number 63, it says, for the following exercises, determine if the relation represented in table form represents y as a function of x. Now, if this confuses you at all, just write those as ordered pairs. So, for example, in 63, we have the ordered pair 5, 3, 10, 8, and 15, 14. 15, 14. All right, so it would be just the same type of problem as number 61 then, if you write it as a set of ordered pairs. All right, so now it's written just in table form, which is just another way of writing it. Okay, so don't let it throw you off. So is this a function of x? Is y a function of x? And yeah, on this one I have 5 with 3, but it's with no other. 10, x equals 10 is just paired with 8, and x equals 15 is just paired with 14. So yeah, it is a function. Number 65. Is y a function of x? Again, you can write that as a set of ordered pairs, 5, 3, 10, 8, and 10, 14. Now notice when x equals 10, y is two different things here. Okay, 8 or 14. So if you write that as ordered pairs, you have 10, 8 in this relation. And you have 10, 14. That's part of your relation there. So x equals 10 is paired with two different y values, all right? Which means that this is not a function. Okay, it's a relation, but it's not a special kind of a relation called a function. Number 67. Here we have a table, table 14. I'm going to refer you to that in your book because I don't want to take the time to reproduce this. There's a lot of entries here. So it says solve f of x equals 1. Well, in other words, what's x when f of x equals 1? That's what it wants. Solve for x, basically. And if you take a look at the table, see if I can get this zeroed in here. Where does f of x equal 1? Right there. Right there. If you look above, what's x? That's 2. So when f of x equals 1, x equals 2. Another way of putting that is f of 2 equals 1. All right? So there's your answer. X equals 2. Number 69. For the following exercises, evaluate the function f at the values f of negative 2, f of negative 1, f of 0, f of 1, and f of 2. All right, so we have f of x equals 8 minus 3x. So f of negative 2 is equal to 8 minus 3 times negative 2. Just plug in negative 2 where you see the x in the formula. And this is equal to 8 plus 6. Negative 3 times negative 2 is positive 6. Again, order of operations, do the multiplying first. Don't go 8 minus 3 is 5, and 5 times negative 2 is negative 10. That's incorrect, because you don't add or subtract before you multiply. Alright, so this is equal to 8 plus 6, which is 14. And then f of negative 1. So that's 8 minus 3 times negative 1. Again, do the multiplying first. That would be negative 3 times negative 1 is positive 3. So this is equal to 8 plus 3, which is 11. All right. F of 0. I like f of 0 because that's usually pretty easy to compute. 8 minus 3 times 0. 3 times 0 is 0, so that's equal to 8 minus 0, which equals 8. And then f of 1. That's 8 minus 3 times 1, which is 8 minus 3, because minus 3 times 1 is minus 3. So 8 minus 3 equals 5. And then finally we have f of 2. 8 minus 3 times 2. So that's 8 minus 6. And that's 2. So f of 2 equals 2. Number 71. We have f of x is 3 plus square root of x plus 3. Okay, so we have f of negative 2. That's 3 plus square root of negative 2 instead of the x plus 3. Be sure that radical sign extends all the way across over the plus 3 as well. Alright, so you know you're including that in the radicand, or under the radical. So this is equal to 3 plus square root of, this is negative 2 plus 3, or 3 minus 2, which equals 1. Alright. And the square root of 1 is 1, so that's 3 plus 1, and that's 4. Then we have f of negative 1. So 3 plus square root of negative 1 plus 3. And that's equal to 3 plus square root of negative 1 plus 3, or 3 minus 1 is 2. Now square root of 2 is an irrational number. You can't simplify this as written. So if you want the exact answer, you just leave it written like this, 3 plus square root of 2. That is the exact answer, which mathematicians prefer, by the way. But you can get a decimal approximation for this. Now, since square root of 2 is an irrational number, when you write it as a decimal, the decimal will not end and it will not repeat. It's like pi that way. Okay, so you can put this on a calculator though and get an approximation. So to emphasize that I have an approximation, I use the wavy equal sign. That means is approximately equal to 4.414. So again, this is the exact answer, and preferred by mathematicians, but engineers and people who use this for practical uses can't really use this in their work. They don't really know what to do with that. So that's because it's square root of 2. Well, what's that? I don't know. Yeah, so you get a decimal approximation, and now you've got some idea as to the measurement you need to make, or what have you. Then we have f of 0. 3 plus square root of 0 plus 3. Oops, forgot my plus. And that's equal to 3 plus square root of 0 plus 3 is 3. Again, square root of 3 is irrational, and this would be the exact answer that you could leave if you're a mathematician. But a decimal approximation, you put that in your calculator. That's approximately 4.732. Okay. Then we have f of 1. So that's 3 plus square root of 1 plus 3. Now this is 3 plus square root of, well, 1 plus 3 is 4. Square root of 4, that one's easy. That's 2. So that equals 3 plus 2, which is 5. And finally we have f of 2. So that's 3 plus square root of 2 plus 3. And that's 2 plus 3 is 5, so we have 3 plus square root of 5. Once again, square root of 5 is irrational, so we could leave it that way as an exact answer, or get a decimal approximation using a calculator. So that's about 5.236. Okay. Number 73. We have f of x equals 3 to the x power. F of x equals 3 to the x. So we have f of negative 2. And you put the negative 2 instead of the x. That's 3 to the minus 2 power. Alright, so if you have a negative exponent, you can write it like this. That equals 1 over 3 to the positive 2 power. And that's equal to 3 squared equals 9, so that's equal to 1 over 9. Okay. And we have f of negative 1. That's 3 to the minus 1 power, and that's, again, can be written as 1 over 3 to the positive 1. 3 to the positive 1 is just 3, so that's 1/3. And f of 0, that's 3 to the 0. And for any real number a, except a equals 0, a to the 0 equals 1. Alright? Now if you have 0 to the 0, that's undefined. So you don't mess with that one, but this is 1. Alright? And then we have f of 1. Is 3 to the 1, which is just 3. And f of 2, that's 3 to the 2nd, or 3 squared, which is 9. Number 75. For the following exercise, evaluate the expression given functions f and h. We don't need g since we're just working the odd-numbered problems on this one. So we have f of x is 3x minus 2. And h of x equals negative 2x squared plus 3x minus 1. So we want f of 7/3 minus h of negative 2. Okay, so take f of x. That's 3x minus 2, so that would be 3 times 7/3 minus 2. So there's your f of 7/3. 3 times 7/3 minus 2. There again, that's f of 7/3 right there. And then you're subtracting, so put a minus. You're going to subtract h of x, which is 3 terms here. trinomial. So put brackets around it because you want to subtract all of h of x, not just a little bit of it. So put all of h of negative 2 in the brackets. All right, what's h of negative 2? It's negative 2 times negative 2 squared plus 3 times negative 2 and then minus 1. So this part is f of 7/3, and in the brackets we have h of negative 2. So we have f of 7/3 minus h of negative 2. Okay, so here the 3's will cancel. In other words, 3 times 7/3 is the same as 3 times 1/3 times 7, or 3/3 times 7, which is 1 times 7, or 7. So we can ignore that factor of 1. Just write 7. And then you've got the minus 2, minus, let's see what we have here. Negative 2 squared. Again, when you do this, you can't multiply first because the order of operations say evaluate the powers first. So negative 2 times negative 2 is positive 4. So you have negative 2 times positive 4. And then 3 times 2 is negative 6, so that's going to be plus a negative 6, or just write minus 6. Minus 6. So when you subtract a number, it's the same as adding the negative of that number, either way. All right? And then you have minus 1. So 7 minus 2 is 5. Minus, then we've got negative 8 minus 6 minus 1. Negative 8 minus 6 minus 1. That's minus 15. So this is minus, a minus is plus, and that's 5 plus 15, which of course equals 20.